Hello, and welcome back to Intermediate GIS, Chapter 2 today on map design. So a lot of the functionality of GIS is not only in its analytical capabilities, but in the ability to make a good-looking map. Time was maps were works of art, and when GIS first came onto the scene, the maps that it made were really clunky. Didn't look really good. So over the past few years, a lot of the resources that have been dumped into the software development have been in the design and cartographic area. So in this chapter, we're going to talk about some design principles, color, how to symbolize data, how to query data so that you're getting the data that you're interested in. It helps with your draw times to query out data that you're not interested in. So we'll get into a little bit of that, and then the assignment we'll talk a little bit about that. It's using these principles to create a map with data that I'll provide to you. So let's jump into some graphic design principles. Let's talk about colors. So maps are a representation of the data, and you can really make that data say anything you want to, depending on how you choose to symbolize it. So in the color realm, high color, dark colors, bold colors, they're perceived as the most important elements on the page. So when you compare, when you have a data set and you have a high contrast, the difference between objects in the background, objects in the foreground that you want to draw attention to, that's called contrast. So when you're developing your maps, keep in mind the first question you always ask when you're developing a map is, what story do I want to tell? And design your map accordingly. What are the elements that are most important? What elements can you live without or live with in the background as reference layers, either for location or other reference data. So this is an example of a map that is showing the percentage of population over 65. Okay, it's a valid data set, but there's just not enough contrast in it to be able to see differences between these 5 categories. So here's a better example of the same data set, same breakpoints, but more contrast built into the color ramp, and so you can start to see the differences. You can see that they're in the Midwest, the upper Midwest, down Phoenix Way in Florida. There's a big chunk of the population that's over 65. Not so much in northeast Nevada, though. So anyway, good use of contrast to differentiate in your color ramps. So when you're building your maps, again, you're wanting to put the most important bits of data, the data that tells the story, as front and center. So you're going to assign bright colors, bold colors to these important elements. This is known as figure. Okay, so you're going to put, when you read in the textbook about putting your features into the figure, that's what it's talking about. They're the ones that are getting the attention. In contrast to that, no pun intended, is your reference data. Data that's there to help tell the story, but it's not about the story itself. That's known as going into ground or in the background. Okay, they're there visually as a reference. They don't lend themselves to telling the story. They're there for reference and background information. So here are 2 maps showing the same data. The map on the left is using the default colors as they were brought into the ArcMap program. So we have red outlines, we have purple streets, we have symbolized points, which we can assume are the story, just because they're symbolized specifically for this map. The map on the right, same data, but those reference layers, the boundaries, the streets, have all been dulled down, they've been put into the background, and the points now stand out as the important bits of data for this map. So you can do the same thing with polygons, with lines. And polygon, you can put a boundary around it to draw attention to it. You can use crosshatch patterns, different fill patterns in your polygons to bring them forward, put them to the back. It's not just limited to points. So let's talk a little bit about color. The human eye is good for seeing color. It's not very good for remembering color. But there are some terms we want to use when we talk about color. Hue is the basic color. Red, orange, whatever the color family is. Okay, the value of the color is the amount of black. So you see there in the bottom right some examples of a green and a red color ramp adding more and more black until they go from green to black, red to black. So that's what the term value means when you're talking about color. Color wheel, everybody's friend when I was in architectural design school. I learned to both appreciate and loathe the color wheel. It's a good tool from a design standpoint to help you pick colors that are complementary. So you can use colors that are on opposite sides of the color wheel to differentiate between graphic features. You can use the rule of thirds, red, blue, yellow, equally spaced around the color wheel for different shading features. Adjacent colors are good if you want to keep things in the same family and not go too hog wild with your bright colors. Now the assignment at the end of this chapter is going to be to take some population data for census tracts and, using a bit of reverse psychology, create an ugly map, not one that is a work of art and beautiful. So keep in mind the color ramp as you maybe think about the colors for your symbology for the population data that I'm going to give you. Alright, so let's talk about color scales or color ramps. As you build these maps and you start to analyze the data, and we'll talk about this in just a second, you're going to make what are called choropleth maps. Probably the most common type of map that you build for analysis. So there are two basic color ramps styles to use in your map in your data when you build your data your maps using your data. A monochromatic color scale goes from white to the hue with the color value. So in this case, white to blue, white to red, uses varying shades of that color. So you're limited to maybe 5 to 6 different shades of the same color before you start to lose differentiation. The other one is called a dichromatic color scale, and this goes from one color to another as it and goes through either white or black in the middle. So you can you use this with data sets that have positive and negative numbers. Think change over time. Positive would be green, negative values would be some variation of red with a white in the middle. And it's very useful for those kind of analyses. So we have an example here of a dichromatic map. Positive, negative, change the number of forest fires. Dark blue is positive, dark red is negative, with the varying shades in between, and center your data on 0. So here's another example. This is change in housing units. I think the author of our book likes Pittsburgh because most of the examples in the assignment data come from Pittsburgh, but here again is an example of a dichromatic map. So when you're picking colors, keep in mind some of these tips. Colors have meaning. Usually if you see blue on a map, it's going to be water. Brown's on a map, land. But beyond that, there are political, cultural meanings. Think of red states, blue states. I attended a discussion at a user conference where the guy spent an hour mapping the same data set over and over using different breakpoints, different styles of the presidential election results from 2008. And it was crazy how different those maps looked as he would pick a different style. So keep in mind, colors do have meanings. Cool colors, warm colors. Cool colors are calming. They kind of tend to recede into the map. Warm colors are excitable. They excite people and can overpower the cool colors. So just keep those in mind when you're building these maps. You can learn more about colors here, colorbrewer2.org. I make no guarantees about what you might find there. Alright, so let's talk about symbolizing the data that we're going to have. So we'll start with points. Point data is just that. It's data that resides and is symbolized by a point. Depending on the scale, points can be anything from a fire hydrant, a telephone pole on a tree trunk, to a city. On a global scale map, cities are represented by points. So here's, when you bring it in, they're all treated the same. So you can use, depending on what's in your data, you can use unique values. So here we have police calls symbolized by the type of call. So you can start to see those relationships. You can use graduated point markers. So if the data set has some numeric value, you can use the graduated point symbols to show where the higher value points are. You can also use industry-specific point markers as you go into the symbology part of ArcMap. You'll see you can pick from hundreds and hundreds of different point symbols, most of which you'll never ever use, never have any reason to use. But at a small scale, remember, small scale, big map; large scale, small map. Small scale, it's gonna get jumbled really fast if you're using some weird industry-specific point marker to symbolize your points. So they're better for large-scale maps, so showing small areas, lots of detail. So again, here we have a zoomed-in map showing the types of police calls symbolized with these funky symbols for weapons, burglaries, and narcotics calls. Alright, so let's talk a little bit about symbolizing lines. Again, you can change the color, you can change the weight of lines, you can use outlines, but again, unless they are the story, they should be put in the background. Okay, grays, light browns. You can also use industry standard lines, mapping the symbols to a style. Roads are something that where there's a standard symbology for roads based on the classification. So you can use an outline on your polygons or not, depending on how many polygons you have. In this example, it looks like we're looking at parcels. If you put a dark boundary around each one, it's going to get really messy really fast, so you might consider removing that outline. So symbolizing the polygons themselves, here we have an example of unique values. Each state has a subregion, so you would map that based on the subregion, and you get a map that looks similar to this. Here we are about choropleth maps, color-coded polygon maps, okay, representing numeric attributes. A lot of the data that you'll use here is demographic data from, say, the census, or you'll learn to love and or hate census data as we go along through this. It can be incredibly frustrating at times to get census data to work. But here we have examples of monochromatic maps that you want your color ramp to kind of make sense. So here we're looking at poverty values. So you want to be able to so you want them to make sense. So here we're progressing from 0 to some value. We want the map on the right with the graduated color ramp, rather than on the left where the colors have no reference to the value. So we go from blue to orange to yellow to red to green, and it just makes it look like somebody ate Play-Doh and then gave it back on the map. So let's not do that. So what kind of data do we want to use? So here for this example we have population, so total numbers. Okay, that's good. Population density, how many people are there per unit of area, square mile or acre or square kilometer. Or a normalized population, so a percentage of the total population that is in an age cohort, for example. So let's look at some examples here from California. So here's the population map. Okay, great, it looks good. We have information. Okay, we see that there's lots of population in Southern California and a little bit in the Bay Area and not so much anywhere else. Okay, so how can we clean that up a little bit? Well, we have some graduated point markers here that we have for the for each county. Okay, so it shows that we have a little more density around the Bay Area. Lots of people live in the South, but those are big counties, and so the population density isn't visually isn't as significant. Here's an actual density map. So this is the population divided by or normalized by the square miles of each county. Okay, so we see in the north, inland north, very sparsely populated. Coastal counties down south and around the Bay Area, high population densities. Another way to symbolize the data is with the dot density map. One dot equals a certain number of people, so this gives you another visual representation of the density. So you can see that the density in Orange County and Los Angeles County are pretty high compared to the rest of the states, or the rest of the counties in the states. Sorry. So here we have a map showing the population over 65. Now, one of the drawbacks or things to remember when you are using this method with the population segment is that you're probably going to get a map that looks very similar visually to the total population map. because it's a known fact where there's lots of people living, there's also lots of people in a particular age cohort. So keep that in mind, that you might get something that looks visually similar. The way around that is to there we go, is to normalize that by the total population. So here we have the same data, population 65 and over, divided by the total population. Now we see something much different. Those same counties that were sparsely populated overall have a very high percentage of persons over 65. So you get all sorts of little nuggets of wisdom out of data when you when you slice and dice it different ways. All right, let's talk a little bit about numeric scales and how to divide up your data. So you're going to, when you build these maps, it's going to ask you what kind of method you want to use for dividing your data into a certain number of groups. You specify how many groups and what method you want to use. Okay, try and keep them fairly small. The eye can't really differentiate much beyond 7 different shades of the same color. So let's talk about some of the basic ones. Quantiles. This is where the data is divided up with equal number in each class, equal number of records in each class. Okay, you never have empty classes, and you never have classes that have a huge number of values in them. Okay, it usually makes for a pretty visually appealing map to use quantiles. So here's an example, back to Pittsburgh. So this is the census tracts, vacant units, and so we're looking at the total numbers in a quantile type numeric scale. Okay, you can also customize your scale. So here we've adjusted the values to where they're doubling each time. Gives a little more differentiation on the low end of the scale. Equal intervals. This is where you set the interval 100, 200, 300. If you have data that's really spread out in distribution, then this might not work as well, because you might end up with classes that have few or no records in each class. Okay, so here we have same data, the vacant units with that equal interval, and we're not getting a lot of differentiation at the low end of the scale. Natural breaks. This is one where the software uses an algorithm, probably developed by some guy named Jenks, to analyze the data and break it into where the algorithm says there are natural breakpoints. It's not a great method. It's really hard to compare between maps, because each data set comes up with a different breakpoint. Unfortunately, this is the default in ArcMap when you go to build a map. So keep that in mind, that the first thing you want to do is change away from natural breaks to a quantile to build your maps. So here's the same data, just in using a natural breaks method. It really does quite it jumps all over the place with the breakpoints, and yeah, I don't know why they even include it. All right, so now we've created this. We redid those maps using a different method, much cleaner looking maps. Okay. All right, let's talk really quickly about queries, and then I'll let you get started on your assignment. Queries. This is where we can pull data out that we really just want, that we're interested in. So you can select data using a tool in ArcMap, where you just select the data. You can also query the attributes, because as you build your map, you've also got a corresponding attribute table that And if you select records out of the table, they're reflected in the map. If you select records out of the map, they're reflected in the table. So they're linked together. Okay, so we use a language called SQL. So we have the basic syntax is field name equals and then a value. Date equals or greater than or equal to. You can also use wildcard symbols, the % sign. So that example there in that second bullet, name like BUR percentage, that'll bring back records that start with the letters BUR. Okay, so that's a tool to make life a little easier. So you have a dialog box where you pick the field name and then your operator, and then right there in the middle you see that Get Unique Values button. If you click on that, it will query your data set, query that field, and return all of the unique values in that field. So that way you don't have to worry about syntax, misspellings. You just double click on the field name, then on the operator, and then double click on the value out of that unique values field to build your query. Okay, you can also combine queries. So we have, you can use and or. So we have the nature COD equals drugs and date 2012-08-01 greater than 2012-08-01. So that will select records that satisfy both criteria. If you were to change that and to or, then you'd get all the drugs and everything that was after August 1st of 2012. Okay. So here you just build that in the same query builder. One thing to keep in mind is you need to build the query each time. So each simple query needs a field name, an operator, and a value, and then and or field name, operator, value. Okay, so you can't say field name equals value or value or value. That's not going to work. So if you see down there in the bottom row of buttons, you'll see that button that says verify. That's your best friend. After you build a query, click that verify button. The software will run the query and then come back and tell you if it succeeded or not, if it was if the syntax was correct. So that'll save you a lot of time to use that button. Okay, so that's a lot of information to digest. We've talked about some design principles, color, how to symbolize your data, how to build queries. So work through the tutorials. That will help you get familiar with the dialogues, the tools that are available for symbolizing data, because again, this is the most important part about building GIS maps. So the assignment for this is not out of the book. On the Canvas page, under the Files section, there is a zip file called uglymapdata.zip that contains a shape file of census tracts with population and area information. So you can build a density map or a total population map. Use that data to create the ugliest map that you can think of. Okay, keeping in mind the principles that we just went through on how to build these maps. Good color choices, good symbology. So yeah, that's the assignment. And then even though it says the winner will be determined by a distinguished panel of colleagues, where this is an online class, we won't be able to declare a winner, but everybody's a winner if you get to where you can turn in a map. So all right, again, questions or anything, I'm available via Canvas to address any questions or issues that come up. Have fun with this one.